Hey guys, in this video we're going to take a peek at how to find the equation of a tangent to a circle. So these are quite big questions, they usually save them for towards the end of the paper. But the good news is they're not impossible. It's a classic case again of using a lot of smaller skills all together to attack a bigger question. So let's get going. Okay, so there's a few things really that we need to be happy with. It really helps if you know what a tangent is. So a tangent is a straight line that hits the circle at exactly 1 point, and 1 point only. Now, it's really important as well to know one of the circle theorems, and that is that a radius and a tangent meet at 90-degree angles. So they're perpendicular to each other. That's a big one. That's pretty much the key to the whole concept. So again, a radius and a tangent meet at 90-degree angles. They are perpendicular. Now some very useful skills for these questions. First of all, it's quite a good idea to be familiar with the equations of circles. So in this video we're only going to look at circles centered at the origin. So the general equation of a circle centered at the origin is x squared plus y squared is equal to r squared, where r is the radius. So that's your general equation of a circle centered at the origin. It's also going to be really helpful to be happy with finding the gradient of straight lines. So remember, the gradient can be found by finding the difference in the y coordinates divided by the difference in the x coordinates. And then finally, knowledge of perpendicular lines and finding their equations is going to be really handy, because that is exactly what we are doing. So let's get cracking if you're happy with all of that. If not, go back, check out the videos on the whatever's giving you doubts. Make sure you're happy, then come back and we'll play with tangents. Cool. So let's get going. Okay, example 1. Here is a circle, centre O, which is the origin, and the tangent to the circle at the point P with coordinates 4, 3 on the circle. Find an equation of the tangent at the point P. Okie dokie, so looking at this, we don't really know very much information, although we do know more than is actually on the picture at the moment. Remember, I said it's really important to remember that a radius and a tangent meet at right angles. It's also really important to realise that this circle is centred at the origin, which has coordinates 0, 0. So what we can do is draw a radius out from the origin, or the point 0, 0, that meets our tangent at the point P, 4, 3. Now remember, the origin has coordinates 0, 0. So now we are armed with two pairs of coordinates for the radius of the circle, of that line segment. So that is all that we need to be able to work out the gradient of a straight line. So we can work out the gradient of the radius. So I'm going to call that m with a little r after it. So the gradient of the radius, now remember, when we're looking for gradients of a straight line, we find the difference in the y values. So here, that's going to be 3, take away 0, divided by the difference in the x values. So here that's 4, take away 0. Now that tells us the gradient of the radius is 3/4. How does that help us? Well, if we know the gradient of the radius, we know that a radius and a tangent are perpendicular. So their two gradients multiply together to -1. So now that we know the gradient of the radius, we can work out the gradient of the tangent. So I'm going to call that mt. So the gradient of the tangent is -1 divided by 3/4. Now when you divide by a fraction, that flips over and becomes -1 times 4/3, which will give us -4/3. So now all of a sudden, we know the gradient of our perpendicular line, of our tangent. So, remember the good old equation of a straight line, y equals mx plus c. M is the gradient, so now we know that the equation of our tangent is something to do with y equals -4/3 x plus c. So, we've done half the work. All that we need to do now is work out the value of c. So, how do we do that? Well, to be able to do that, we need to know the gradient of our line, check, and we need to know one pair of coordinates, check. We know that, we've got point P. So, to work out the value of C, we substitute in the coordinates at point P. So, that's telling us when x is equal to 4, y is equal to 3. So, we would get 3 is equal to -4/3 times 4, because x is 4, so -4/3 times 4 is going to give us -16/3, like that. And then we've got plus c. Now we need to get c on its own. So, what would 3 on the left-hand side be in terms of thirds? Think about pizza. If you've got one whole pizza, you can cut it into 3/3. So if we've got 3 whole pizzas, not only are we really happy because of all that pizza, but we can think of that as 9/3 of a pizza. So if we add that 16/3 to the left-hand side, 9/3 at 16/3 is 25/3. So C is 25/3. Now we've got everything that we need to write down the equation of our tangent. So we now know the gradient, we know C, so the equation of our tangent is y is equal to -4/3 x, and then add C, so add 25/3. That is the equation of our tangent. Jobs are good. Okay, example 2. So, we're not always just asked outright to find the equation of a tangent. Sometimes there's other mysteries to be solved. So here with this question, this circle has equation x² plus y² equals 10. Now we can see the tangent hits the circle at the point A, where the x-coordinate is 1, but we don't know the y-coordinate, and the tangent hits the x-axis at point Q, where we don't know the x-coordinate, but we do know the y-coordinate is 0. Everywhere on the x-axis, y is equal to 0. So here, what we're going to do, we're going to find the missing y-coordinate of point A, and then we're going to find the missing x-coordinate of point Q. To do that, we're going to need to know the equation of the tangent. Okay, so let's get cracking on point A. So, when we're doing things like this is where the equation of the circle is useful to us. So we know x² plus y² is equal to 10. Now remember, if a point lies on a line or a circle, then it will satisfy the equation. So, if we substitute in the x value, which we know is 1, that will leave us an equation strictly in terms of y, and we will be able to work out the value of y. So, let's plonk in x equals 1, then we're going to get 1 squared plus y squared is equal to 10. 1 squared is 1. If we take away the 1, we get left with y squared is equal to 9. So, to find the value of y, we're going to square root both sides of this Remember though, when you square root and you're playing around with algebra, you get two answers. So we would actually get y is equal to plus or minus 3. So how do we know which value we're going to use? Well, look at the graph or the drawing. We can clearly see that the point A is above the x-axis, which means that y is positive. So we're going to take y to be equal to plus 3. It's important to realise the point y equals minus 3 does also lie on the circle. That would be over here somewhere. Okay, so our point A has coordinates 1, 3. So we needed to find that missing coordinate, because now now we can play around with the radius again, work out the gradient of the radius, work out the gradient of the tangent, work out the equation of the tangent, then work out the x-coordinate of point Q. Okie dokie, so let's do just that. So again, remember, this circle is centered at the origin. So we can draw a line out from the origin to point A. Now again, also remember, at the origin, we have coordinates 0, 0. So now we have all the information that we need to be able to work out the gradient of the radius, because we know the two coordinates, or the two coordinate points at each end. So the gradient of the radius, again let's call it r. Well, it's the difference in y values, so 3 take away 0 divided by the difference in x values, so 1 take away 0. Now 3 take away 0 is probably 3, and 1 take away 0 on a good day is 1. So we've got 3 divided by 1, which is going to give us 3. So the gradient of the radius is 3. Now we can find the gradient of the tangent. Remember, the two lines are perpendicular, so the gradient of the tangent is minus 1 divided by 3, minus a third. Cool. Now we know the gradient of the tangent, we can start filling in y equals mx plus c. So we know the tangent is something to do with y equals minus 1/3 x plus c. Cool. Okay, so now remember, to find the value of c, we need a pair of coordinates. Happy days. We know the coordinates at point A, 1, 3. So that's telling us when x is equal to 1, y is equal to 3. So if we substitute those in, we get 3 is equal to, or minus a third times 1 is minus 1/3 plus c. Now again, we need to get c on its own, so we need to add that 1/3 to both sides. So again, imagine the 3 on the left hand side in terms of pizza. If you've got one whole pizza, you can cut it into 3/3. If you've got 3 whole pizzas, you've got 3 lots of 3/3, you've got 9/3. So if we now add that 1/3 to the right hand side, we get the value of c to be 10/3. Cool. So now we know, or we can write down now, the equation of our tangent, because we know the gradient and we know the value of c, the y-intercept. So let's do just that. So the equation of our tangent is y is equal to minus 1/3 x plus 10/3. So that right there is the equation of our tangent. Now we're not quite done here. Remember, what we want to do now is find the x-coordinate of point Q. So we know that y is 0 because we're on the x-axis. So what we're going to do then is substitute in y equals 0 and then solve for x. So we would get 0 is equal to minus 1/3 x plus 10 thirds. Then if we add the 1/3 x, we're going to get 1/3 x is equal to 10 thirds. Now 1/3 x is exactly the same as x divided by 3. So to cancel out a division by 3, we multiply both sides by 3, and that's going to tell us x is equal to 10. So the coordinates of Q are 10, 0. Job's a good one. Okay, we're going to do one more example. Okay, here we go then. So we've got a 3-part question here. We've got an A, B and a C. But we'll be alright. Nothing to be scared of. Okay, so A and B are points on the circle with equation x squared plus y squared is equal to 25. A is the point with coordinates 4, 3, and B is a point on the y-axis. So PA and PB are both tangents to this circle. Now the first thing that we want to do then is show that the coordinates of point B are 0, minus 5. So there's two ways that we could go about this. Two ways we can think about it. Remember that the general equation of a circle centered at the origin tells us that x squared plus y squared is equal to the radius squared. So here we've got x squared plus y squared equals 25. That tells us r squared is equal to 25. Now if we square root that, remember the radius is a physical quantity, it's a length. So it doesn't make sense to have a negative answer. So when we square root the radius squared, we just get the radius is equal to 5. Now that tells us any point on the circle is exactly 5 units away from the centre, the origin. So that means this point over here would be 5, 0. This point up here would be 0, 5. This point on the left would be minus 5, 0. And then finally, this point here would be 0, minus 5, as we wanted it to be. Now there's another way we can think about it, and that's by substituting in the value of x. So we're on the y-axis. We know if we're on the y-axis, x is equal to 0. So we would get 0 squared, add y squared is equal to 25, which gives us y squared is equal to 25. Now there's a very subtle difference here compared to when we were playing with the radius squared. It didn't make sense for the radius to be negative, but y is just a coordinate point. So when we square root y squared, we do get y equals positive and negative 5. So that would tell us the y-intercept up above, the value of y would be positive 5, down below the value of y is negative 5, as we want it to be. Two different approaches, same answer, showing the same thing. Okay, part B. Give a reason why PA is equal to PB. So this comes down to a bit of circle theorem knowledge. If you have two tangents of the same circle, then at the point where they meet, they are going to be exactly the same length. So the reason is that they are both tangents. Nothing complicated there, just one of the circle theorems. And now part C, this is where the geometry gets heavy. So P is the point AB, work out the values of A and B. So we want to work out the coordinates of the point where these two tangents intersect. Now the good news is, we already know half of the answer. So remember that a tangent and a radius meet at right angles. So down here at point B, the radius is the y-axis. So the tangent, which is perpendicular, is coming out at exactly 90 degrees. So it's just coming straight across from the point where y equals minus 5. So we know the y coordinate of point P then. We don't know x, so let's leave that as point A, or A. But we do know the y coordinate is minus 5. So that might lull us into a false sense of happiness, thinking we've already got half of the answer. we haven't done half the work, sadly. So, to work out the value of A, we're going to need to find the equation of the tangent PA. So, we're going to do that in exactly the same way we've done it in the last few questions. Start by drawing a radius. Now, we know that radius comes out from the origin, so the point 0, 0. Okay, now that we've got the radius, we know its two coordinate points, we know its beginning and its end, the centre of the circle and the point on the circumference. We can now work out the gradient of Mr. Radius. So, the gradient of the radius, I'm going to call it MR. Well, that's going to be, remember, it's the difference in y values divided by the difference in x values. So here, that's going to be 3 divided by 4. So, 3/4. Now, we can work out the gradient of the tangent, which is -1 divided by 3/4. Now, if we do -1 divided by 3/4, that's the same as -1 times 4/3, which gives us -4/3. So, the gradient of our tangent is -4/3. So now we can start filling in the gaps in y equals mx+c. We now know y is equal to -4/3 x plus c. Jobs are good. Okay, so now we fill in the coordinates from point A to find the value of c. So that's telling us when x is equal to 4, y is equal to 3. So we get 3 is equal to -4/3 times 4 minus 16/3 plus c. And then we need to add that 16/3. So again, think of the 3 on the left hand side as 9/3. Add 16/3. We then get c is equal to 25/3. Now, if this is looking familiar, it's because this is the same tangent that appeared in question 1. So, the equation of our tangent is y is equal to -4/3 x add 25/3. There's the equation of our tangent. Now we want to find the value of A at the point P. Now we know down there y is equal to -5. We don't know what x is, that's the point. But we're going to substitute in y equals -5. So we're going to get -5 is equal to -4/3 x plus 25/3. Now that we got rid of y, there's something really nice we can do here to make the job a little bit easier, and that is to multiply everything by 3, which is going to get rid of the fractions on the right. So that would leave us with -15 is equal to -4x add 25. Then if we subtract 25, we're going to get -40 on the left is equal to -4x. And now we can divide both sides by -4, and we get 10 is equal to 1x. So the coordinates of point P are 10 minus 5. Jobs are good. Okay guys, I hope that's helped. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers guys.